Hi, and welcome to Becker Breaks It Down. In this episode, we are going to look at something called arc length. So previously, we've been finding measures of arcs, like actual degree measures of arcs. Like in this little comic here, he's like, pass me that big slice with the 45-degree angle. Because as you know, the measure of an arc is equal to the measure of its corresponding central angle. Okay. But arcs also have a length, like how long is the arc? Okay, so like in this scenario, they're talking pizza, and we know the radius of the pizza is 8 inches. So like the arc length of the pizza would be like the crust, the outer crust of the pizza. So like how much outer crust is there? Okay, well, as you know, if you go completely around a circle, that's called circumference. So arc length is simply a portion of the circumference of the circle. Okay, and circumference is found by going 2 times pi times the radius. So we just want to find a fraction of the circumference. So we're just going to multiply the circumference by theta over 360. Theta is representing the measure of the arc. Okay. So we're finding the fraction of the circle and multiplying that fraction by its total circumference, and that's going to give us arc length. Okay, so when the vertex of the angle creating the arc is at the center, then the measure of the arc and the measure of the angle are the same. Okay, so you will need to pay attention to the angle creating the arc so you can accurately find its measure. Case in point, example 1. Says if the radius of the circle is 24 centimeters and the measure of angle BTA is 60, what is the length of arc AB? Well, as we know, the length of that arc is equal to the circumference of the entire circle times theta over 360. Theta is the degree measure of the arc. So we need to ask ourselves, what is the measure of the arc here, right? So we've got an angle whose vertex is on the circle. This angle, when you extend it, you come to arc BA. So we need to be like, what's the measure of arc BA? Since the vertex is on the circle, 2 times the measure of the angle is going to be equal to our arc. So our arc here is 120 degrees. So now that we know what theta is, and they gave us the radius, we're ready to calculate our arc length. Okay. So I have 120 degrees over 360. 120 is the degree measure of our arc. And then I have 2 times pi times 24. After all, they told us the radius was 24 centimeters. So then I'm just doing the math, and I get that my arc length is 16 pi centimeters. And you could totally multiply by 3.14 to get an approximate measure. So let's take a look at another example. What is the length of arc ROT? We actually know the length of arc ROT is 116 pi meters. What is the radius? Well, we're working with a formula, right? So my advice is to follow the steps. Formula, substitution, solution. Okay, so we want to fill in everything that we know. We know the arc length, and we technically know theta, the degree measure of our arc. If you look at your circle, 120 is not the measure of arc ROT. ROT would be 360 minus that. So we do need to do that math, but we know that it would be 240. So I'm just going to substitute everything I know into my arc length formula. And then it's just a matter of simplifying this and, well, eventually solving for R. Okay, so the first thing that it looks like I did was I simplified 240 over 360, and I said that was 4/3. Actually, it looks like I did all this math. I did 240 over 360 times 2 pi is 4 pi over 3. Okay, so that makes sense. I'm multiplying both sides by the reciprocal because that's the same as dividing by 4 pi over 3 is multiplying by the reciprocal. And so after all of that, I get the radius is 87. Okay, and then in the last example, it says circle F has been divided into sectors. The length of FB is 3 units. If you look at the circle, FB is the radius, so we know what R is. Find the length of arc AED in terms of pi. So AED would be this arc right here. So the first thing that we need to figure out is what is the measure of that arc? That's going to involve us going like 360 minus 120 minus 45 minus 30. So we're going to get 165 degrees for the measure of our arc. So we can just plug that in to our arc length formula. And that's what you're seeing here. You've got the 165 over 360, and then you have 2 pi times the radius. So when we multiply that out, we get 990 pi over 360, which is simply 2.75 pi. And that would be our arc length. So arc length is just a fraction of the circle, right? And we figure out what fraction of the circle with the theta over 360. Theta is the measure of the arc. And then we simply multiply that fraction by the circumference, and that's how we find arc length. And that's how Becker breaks it down.